Hello, Finxter. This is Antti. Today, I will guide you through my article about np.diff on Finxter.com. And so in Python, the np.diff function calculates the nth discrete difference between adjacent values in an array along with a given axis. For higher order differences calculation, this function runs recursively to the output of the previous execution. And in this video, I will first introduce its syntax and arguments. Then I will show you some basic examples of using this function. After that, I will address 3 top questions regarding this function. And last, I will summarize our topic today for this function. So first, let's take a closer look at its syntax and arguments. So here is the syntax of this function, and here is an argument table of this function. So I think if I place these two in one page, then you can comprehend this function in a better sense. So first, this function accepts an input array. This input array is the array that will take the difference calculation on later. And then after this first argument, here are the 3 optional arguments. They are the n argument is about the number of times values are differenced. If we set n to be 0, then the input will return the input array as it is. Which means it will does nothing to the input array and output the same input array, the same array with the same values. It's not actually the same array. It will just return a new array actually, but the new array with the same values as the input array. Yeah. And our third argument here, the axis. Which is the axis along which the difference is taken. The default value for this axis argument is the last axis. And our last argument, prepend or append, is it values to prepend or append to a long axis prior to performing the difference. So for our later tutorial, I will explain these two, the n and the axis in our basic example, and I will explain this argument, prepend or append, in a later section about which is called np.diff prepend. So now we understand where we have the first impression about the syntax and arguments of this function. Now let's take a look at a few basic examples of this function. First, let's take a look at how to get a 0 difference and the first difference in a one-dimensional array. Let's take a look at what this code does first. So first we import numpy as np. np is the alias for this library numpy. And we initialize a one-dimensional array, and we assign this one-dimensional array to a variable called one_dim, and we code the np.diff function twice. Each time we pass the one-dimensional array as the input array to this np.diff function. The only difference is that on this line we set n to be 0, and in the next line we set n to be 1. So if we set n to be 0, what we get is a new array with the same values as the input array. So I named this variable code itself. And for this line, since we set the n to be 1, that means we will get actually it should be the first difference, but here I just name it as one_diff variable. After that, we print out the original array and the 0 difference output and the first difference output. And now if we run this code in our terminal here, then we can get the output here. As you can see, the one-dimensional array is 1, 2, 4, 7, 12, and our zero difference is actually with the same values as the input array, 1, 2, 4, 7, 12. But how do we get the first difference, 1, 2, 3, 5, which is actually not so obvious as it is, right? It's not very obvious. Then how can we get this first difference array? To explain this, please follow me on this comment. So actually the first difference is given by this formula here. The ith element in the output array equals the I plus 1 element in the input array and the ith element in the input array. So let me explain this again. So the ith element in the output array equals to I plus 1 element in the input array minus ith element in the input array. This is formula that derive the first difference array here. So let me write you through some basic examples here. For example, the output array, the first element in the output array, since the index for array starts from 0, so that's why I write 0 here for the first element in the output array. So the first element in the output array, according to this formula here, equals to the first indexed value in the input array minus the 0 indexed value in the input array, which is 2 minus 1 equals to 1. And that's how we can get the 1 in this first element of the output array. And what about the 5? How can we get this 5? So first we count the index of this value. So 0, 1, 2, 4, 1, 2, 3. So how can we get the 3 indexed value in the output array? According to this formula here, it should be the 4 index value in the input array minus the 3 index value in the input array, which equals to 12 minus 7 equals to 5. So that's how we get the 5 here. So after this first basic example, I hope you understand how the numpy.array calculates the first difference under the hood. Now, let's take a closer look at how it calculates the second difference and third difference, namely higher order differences. So here, higher order differences are calculated by using diff recursively. Okay, I know this may sound confusing to you at first, but just follow me on this code and I will explain this to you. So first, we import numpy as np, and we use the np.array, initialize a one-dimensional array, and we assign this array to a one-dim. As previously, we call np.diff many times, here 3 times, and we pass the one-dimensional array each time to this function as the input array. And each time, what's the difference is that we set different value to our n. If we set n to 1, then we get the first difference value, and if we first difference output. If we set n to be 2, we get a second difference output. And if we set n to be 3, we get a third difference output. And we print out the original array and the first difference, second difference, and third difference respectively. After running this file in the terminal, we get this result or this output. As you can see, the original array and the first difference array already appear in our previous case, and I already explained how we can derive the first difference previously. Now, what I want to explain further is how we can get the second difference and third difference, and namely, what does it mean to, using difference np.diff recursively. What does this mean actually? So it means the second difference is based on the first difference, and the third difference is based on second difference. Still, this is still very abstract, but let me explain this to you on here. So as you may recall that the first difference is calculated like 1 is calculated 2 minus 1 here, right? And the 2 here is 4 minus 2 here. That's how we can calculate the first difference here. So since, as I mentioned before, the second difference is based on the first difference. So it actually means the 1 here is derived by 2 here minus 1 here, and 3 here is the 5 here minus the 2 here. That's what it means. The second difference is based on the first difference, and the third difference is based on the two differences. Like the second difference, sorry, is like the 2 here equals to 3 here minus 1 here, and the minus 2 here is actually the 1 here minus the 3 here. That's what the using diff recursively actually means. So the second difference is based on the first difference, and the third difference is based on the second difference, and so on and so forth. That's how the np.diff function calculates higher order difference under the hood. Next up, let's take a look at access here, and access in our argument table as well. So our next example is calculate the second difference in a two-dimensional array with axis equals to 0. Here, axis is an argument in the np.diff function. Now, let's take a look at this code first. As usual, we import numpy as np, and we initialize a two-dimensional array here using np.array, and we assign this two-dimensional array to a variable called toDime, and we call np.diff twice. Each time we pass the toDime two-dimensional array to this np.diff function, and each time we set the axis to be 0. They are all 0, and the only difference is that in the first call we set n to be 1, and in the second call we set n to be 2, so they will get the first difference and second difference respectively. And after that, we will print out the original array, the original two-dimensional array, and the first difference result and the second difference result. And after running this code on, we get this output here. So for the original array, we get a two-dimensional array, and for the first difference, I should explain this for you, the first difference. But before I explain this for you, actually, you have to understand what it means to set axis to be 0. So if here is a two-dimensional array, just imagine it like a matrix. Axis equals to 0 is like here. It's by row, and if you set axis to be 1, then it's by column. Just remember this here, and then we take a look at how we can derive first difference in a two-dimensional array first. So here is our two-dimensional array. This 3. How can we calculate this 3? So it's 4 here minus 1 here. Why? Why is that? Because remember, we set axis to be 0, and it's by column. By column, it's like, let me draw this here. It's like 1, 2, 4, 9 and blah blah. And the second row is like 4 2. I'm just copying the two-dimensional right here. 3 4 3 4 2 1 0 blah 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 blah. And if you want to calculate the first difference along the 0 axis, then this first element should be the 4 here minus the 1 here. That's how we can calculate the first difference in a two-dimensional array with axis equals to 0. And you can extrapolate this calculation method for the first difference. And for the second difference, since I already explained the higher order differences calculation way, you can understand where the minus 4 comes from, right? It comes from the minus 1 here, minus 3 equals to minus 4. And that's our example of calculating second difference in a two-dimensional array with axis equals to 0. And in this example, you understand first what it means to set axis to 0 and axis to 1 in a two-dimensional array, and actually how to derive first difference and second difference in a two-dimensional array. And next, let's take a look at another example about calculating second difference in a two-dimensional array with axis equals to 1. And this example only differs from the previous example here, right? The previous example is all about setting axis to 0, and here we set axis to 1 here. And other code components are the same as the previous example. So let's just take a look at its output directly. As you can see, as you may recall, so first, axis equals to 0 means by column, by row, and if we set axis to be 1 in a two-dimensional array, then it means by column. And if we, in this case, we set axis to be 1, then in this case, we are doing the difference calculation by column. So the 1 here actually is derived by 2 minus 1, and the 2 here is derived by 4 minus 2. And as for the second difference, since it's based on the first difference, right? Second difference is based on the first difference, and first difference is based on the original array. And the second difference, the 1 here, is derived by actually the 2 here minus 1 here, and the 3 here is derived by 5 here minus 2 here. And you got the idea. So that's our final basic example. Now let's take a look at our third part, np.diff prepend. Prepend, if you remember, is another argument of this function, np.diff. And for this part, I just first show you the argument table of this function to recall your memory, to jog your memory that actually prepend appears previously in our argument table. And intuitively, I will show you that. For example, if we have a basic operation here, 1 plus 2, if I want to prepend something to this operation, I can prepend what? I can prepend 1 plus here, right? I can prepend this here. After that, I can also append something after this operation. I can append like plus 3 here. That's a concept of append, right? So basically, this is how to understand prepend and append intuitively. And back to our argument table. The description for this prepend and append is that values to prepend or append to a long axis prior to performing the difference calculation. And for a further explanation, it just says that there are 2 ways that you can prepend and append. The first way is array-like, or I should say array-like, and the second way is scalar value way. And in this part, I will show you the array-like way first and show you the scalar value way after that. So first, let's take a look at the array-like way to prepend. By the way, since the prepend and append, they are similar. I shouldn't say that they're basically the same, but their idea are quite similar. So in the next two examples, I will only explain how to prepend in the two ways, array-like way and a scalar value way. So I will leave the append argument for you to figure out after this tutorial. So without further ado, let's take a look at the array-like way to prepend. Let's take a look at the code itself first. So we import numpy as np as usual, and we initialize a two-dimensional array here, and we assign this two-dimensional array to a two-dim variable, and then we call np.diff twice, and we get the difference is that and we call the np.diff function twice, and each time we assign the two-dim variable declared previously to the function, and we set access to be 0. To jog your memory, access to be 0 is by what? It's by row, right? In a two-dimensional array, and we set n to be 1, n to be 2, so we will get first difference and second difference respectively. And our new friend here, prepend, is this may sound very complex, but I write a commented code here. This two line is actually equals to this two line. What this does is using Python feature, list feature. This is like if you can understand times 3, it is equals to 1, 1, 1. It's the same as this. The difference is that the 3 here is the column length of this two-dimensional array. So here it will evaluate to the column length of this two-dimensional array, and the result is actually the same as here. The way I write this, why I write this is like I want to prepend the same size of the input array. I want to match the size of the input array, so I write the way like this. But if you know beforehand about the size of the input array, and you can actually do it in a hardcode way. But I write in this way. I hope you can understand. But anyway, after that we print the two-dimensional array and the first difference result and the second difference result respectively. And let's take a look at its output. The two-dimensional array here, and the first difference result here, and the second difference result is here. So for the first difference result, as you can see previously, if our input array is let's say has 3 rows, and after the first difference, actually the first difference result will be 2 rows, right? But here our first difference has 3 rows. Why? Because we prepend something, right? That's why we prepend something. Is like we add an extra column, an extra row here, which is 1, 1, 1, blah, 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 1 here. So the 0 actually is derived by 1 minus 1, and the 1 here is 2 minus 1, and the 3 here is 4 minus 1. That's why we have 3 rows here, and that's what the prepend actually means. It's about prepend an extra rows if we set access to be 0, or prepend an extra column if we set access to be 1, and it's all about prepending something before the difference calculation. And it's the same idea for the second difference. is based on the first difference. So the 3 here is actually the 3 minus 0, and the -1 here is 0 minus 1, and this is how we can calculate the second difference here. So this is the array-like way to prepend something. Just to jog your memory, just take a closer look at how we can prepend something in a array-like way. And next, let's take a look at another way to prepend, which is scalar value way to prepend. The code is much cleaner. And as you can see, the other parts of the code are the same. Only here, the prepend, we just pass an integer 1. And this does exactly the same effect as the previous code. It will actually, the code is the same as the code here. I mean, their effect is the same. Their effect are the same. And if we run this code, we get the same output as our previous example. So this is a scalar way to prepend. So in conclusion, you can either pass a scalar value or array-like something to prepend or append to an long access prior to performing the difference calculation. But it is easier to pass a scalar value, as you can see, if you just want to prepend or append the same values, right? And the array option gives you the flexibility to structure any values that you want to prepend or append. So if you only want to append 1, in this case, you can just pass 1. But in that case, you want to pass like 1, 2, 3, and different values. I think you should choose to use the array-like way to prepend or append. So let's take a look at our fourth part, np.diff versus np.gradient. So this is another confusing point about this function np.diff. That what's the difference between np.diff and np.gradient? So far, I hope you have a better sense of this function np.diff. What does this do? What does this function do? And how can we use this in a basic sense, right? But for this function, this may sound very unfamiliar to you. Simply put, this function here, np.gradient, is used to measure the change rate in a n-dimensional array, which is like the slope concept in a two-dimensional plane. So as you can imagine, intuitively, the difference is that this function, the underlying calculation for this function only has to do with subtraction, only about subtraction. But this function, under the hood, the calculation is about subtraction and division, right? Because it's like intuitively, it's like the slope concept in a two-dimensional plane. So this is about the intuitive way to understand these two functions, the difference between these two functions. For now, I hope you know intuitively what the difference is between these two functions. By the way, I have written another article on np.gradient and will record a video on that function. If you'd like to know more about the np.gradient, please check out my article and stay tuned for my further video. And our next part is about np.diff datetime. So in our previous examples, we have only dealt with numerical values, but good news, the np.diff method can also be used to actually handle datetime format arrays. And here is an example of handling datetime format arrays. Actually, so first we import numpy as np, and we use np.range to initialize datetime format arrays, and we call the np.diff function to calculate the first difference of this datetime format array. And after that, we print out the original datetime format arrays and the original arrays type. We just want to make sure that it's datetime format. And then we print out the first different result and the type of the first different result. And let's take a look at this output. So first, the type of the original datetime format array is actually, yes, datetime format. But take a look at here. The type of the difference, the first difference array is actually time delta. So please be aware that generally the type of the np.diff function's output is the same as the type of the input array. So previously, when we are dealing with integer, right? If we pass an integer array, the output, I mean let it to be the first difference, second difference, or blah blah, the difference. Their result will be integer array as well. But here, if our input array with a type as datetime, then the output array type is time delta here. So this is a notable exception. So this is a notable exception because actually, yes, what should I say? The difference between the datetime element here is the time delta type is with the time delta type. So this is a caveat of handling datetime format arrays using np.diff. I hope you understand this notable exception now. And that's it for our numpy.diff article. We learned about its syntax, arguments, and basic examples. We also worked on the top 3 questions about the numpy.diff function, ranging from numpy.diff prepend, numpy.diff versus numpy.gradient, and numpy.diff datetime. I hope you enjoy all of this and happy coding. Bye bye.